Hi everyone, we're continuing on from the previous episode where we put in the legwork making this system which is going to be taking care of our surface audio sounds. One thing that we did do in the previous episode, we duplicated this system across so that we had 3 others, so that we had a total of 4, and essentially each of these Metasounds are going to be getting attached to each of the wheels so that they can emit their own unique sound based on what the wheels are driving on. We went over the subtle differences that we need to take into account for each of these new Metasounds, so if you haven't done that yet, you have to go back to the previous episode and then you'll be ready to tackle this one. Now without further ado, let's get into the event graph. Now the first thing we need to do is add the Metasounds into the component section of our player control blueprint. In this case it's a wheeled vehicle pawn. So go to the event graph here, and if you just go to this component section and you highlight the Metasounds which we need to add in, so the front left here, surface audio front left, if I press add, you can see here audio, Metasound, sound effects, surface audio front left. So you click that, you add it in, and it will add it to this component section. You have to do the same for each of these. So if I go to the surface audio front right here and I press add, you'll see here surface audio front right. So go and add in all 4 of those Metasounds that we created from the previous episode and we'll be ready to continue. One thing I almost forgot to mention is that when you add in these Metasounds, you need to place them correctly at the wheel. One way you can actually do that is you can give it a parent socket. So if you know what this bone is called, so on my car I know that this bone is called FL, so I can just click on that. You can actually select it here, so you can see I've got the bones of my wheels, and I can attach the front left speaker of that Metasound that we've added into our list of components to that specific bone, so the front left, so that speaker just gets attached to that location. And it's the same with the front right, the back left and the back right. I'll just get rid of myself for now. If I press Ctrl Shift 1 I should be off the screen now. The other thing I wanted to mention was these settings here, so the attenuation volume and attenuation spatialization settings. This is important for how these tyres sound when you're driving the car. So say for instance you're on the bonnet cam, or maybe you have an interior position on your camera. So let's say you're in the body cam, you've got your front left tyre here, your front right tyre here, and they're all going to be emitting their sounds. And we kind of want Unreal Engine to take care of the spatialization of those sounds so that we get a nice stereo image, essentially. So what I want you to do is look at the way I've set up my settings here. So on attenuation, we are allowing spatialization true, override attenuation, we're also setting to true. On attenuation volume settings, take note of how I've set these up. So enable volume attenuation is on. The function we're using is inverse. We're using sphere. The inner radius, which is essentially this circle here, is 619, and the fall off distance, which is the larger circle on the outside, is 443. On the attenuation spatialization, we are enabling spatialization here and we're using it as panning essentially. If I go across and look at each of these different Metasounds, you should be able to see that they all have exactly the same settings. So that's just something to keep in mind. Make sure that your settings match mine and all this should work perfectly for you. Now the first thing we're going to have to do is essentially find out what surface each wheel is driving on. Now this feeds into what we did in the previous episode where we set up physical materials that are essentially on the floor or on meshes. So the way we're doing that is we're using a custom event that we've created called surface audio. This custom event is being called via a call function. If I zoom out and go up, it's being called actually from the event tick. So if I go to event tick and go to surface audio, there it is. If I double click on this, it takes us back to the custom event, and that means every single frame this is firing off into this sequence. The reason we're using the event tick is because it's a wheel, and the wheel is always in contact with the ground, and there's really no way of us defining when anything should happen without constantly checking. So it's a little bit different from footsteps, for instance, With footsteps, you would set up something called an animation notify, so that when an animation gets to a certain point in its cycle, you would send through an event, and then that event would shoot off through this, for instance, and then we could go through a sequence and figure out what we want to do with those footsteps. A wheel is obviously different. It's always in contact with the ground. Therefore, unfortunately, it's a little bit more intense on the computer to figure out, what we should be doing with the surface sounds. So I just thought I'd mention that. If you can think of a better way to do this without using the event tick, I'd love to hear it, because that would help me out a lot, to be honest with you. But this is the best way I could figure out of doing it. So out of the sequence, we're then going out into line traces. Now this is where we're now going to figure out what each wheel is doing. So from 0 to 3, we're going out to these line traces. I'm actually going to go and select this line trace, which is for our front left, and I'm going to set the draw debug type to for duration, and the duration is based on this, so 10 seconds. So what that's doing is it's shining essentially a laser down into the floor, and that laser is going to be firing off every single frame, and it's going to stay on the screen for the essentially 10 seconds, which is defined here. Now this area here coming off into the start and the end, I'm going to read it from here. What is this line trace FL? If I go to my viewport, what that essentially is, if I type it into my components, line trace FL, so you can see that here, you can see there's this little invisible dot that is by our wheel. What that is, if I type into this section here, actor, it's a utility and it's a child actor. If you click that, it will create one, and it will usually spawn in the center of the world here inside of the viewport. And then once you've done that, I would drag it off and place each one, so 4 independent child actors at each of these wheels. So you can see we have one here, and I've named it line trace FL for line trace front left, and it is here on the front left tyre. If I go here, line trace FR, you can see we've got one on the front right tyre, and BR, one on the back right tyre, and BL, one on the back left tyre. So we're using these child actors essentially to depict where this line trace should start. So we're dragging out those child actors, so it's a simple case of just dragging this into your event graph. We're dragging them out, and then we're going get world location. And then from the get world location, we're feeding that into start. We're also feeding it into a subtract, and then the subtract on this vector is then going to the end. So we're saying subtract 50. That's a way of saying we want to shoot this line trace downwards into the floor. We're shooting it down. I don't know if it's like 50 pixels. I'm not entirely sure what the actual name it is that we're dealing with here, but we're shooting it down 50, and that is going to shoot it down into the floor. And from there, that line trace can give us information such as, are we driving on a certain physical material, which we set up in the previous episode, for instance, asphalt. So we're doing exactly the same thing for each of these, but you can see the only thing that's changing is the actor that we're using. So this is line trace FL, this is line trace FR, this is line trace BL, and this is line trace BR. Other than that, it's exactly the same setup for each of these. In a moment, I'll go over what's coming out of then 4, which is going sort of down here. I'll cover that in a moment, but let's just continue on with essentially this setup going forward. So out of the line trace, I do want to show you the line trace actually being drawn. So I've got the draw debug option set to full duration and 10 seconds, which we went through before. If I go into the world and press play now. Okay, so now that we are playing, you can see there's a red laser shooting down into the ground, and if I drive forward, you can see it tracks across. Eventually it will disappear behind us. But what that's essentially doing is it's shooting down, and it's saying, once we set up correctly, it's going to tell us what we're driving on is asphalt. Now if I move across and I go to this, now what it will do is it will tell us what that wheel is on is an apex. If I move over here, it'll tell us it's grass. If I find some loose gravel, it will tell us it's loose gravel. So that's essentially what the line traces are doing on each wheel. It's just shooting down, and basically we're going to be setting it up now to tell us what is that line trace interacting with in terms of the physical material. So the first thing we're doing is we're carrying off this execution pulse over to a branch, and then we are saying our hit, and we are getting the surface type. You can basically ignore this break hit results, but I wanted to have it in there just to show anyone who's quite new to line traces all the different types of information that you can get from a line trace, because this sort of stuff is really useful for when you want to get into the nitty gritty and start to get the most out of the line traces. So you don't have to put that in now, it's just for me showing you that you can break that hit results and you can get a load of information about the line trace. So we're getting the surface type. This surface type, if we follow this sort of greenish line over, is going to this call function. So that means it's heading to a custom event that we've created. So if I double click this, you can see this is the custom event we created. It's called LF Tire Sound. And this custom event has something that we've added called surface physics. And it's an E-physical surface type, which is like an enum, I believe. So if I type in E-physical, you can see it's an enum. So E-physical surface type. So I believe it's that one there, if I'm not mistaken, but that's the exact name of it there, E-physical surface type. So once you've got that, the call function that you can then create from that can receive this data. And this is ultimately what's going to be able to tell this coming out of here what physical surface we're on, where we're going to be using a switch to go across different surfaces and essentially get the correct sound that we want. So that's essentially what's happening there. So off camera just then, I just made a few slight changes to the code. Originally, I had this coming off and being the condition for this LF in here. Instead, what I've done is I've detached that and just mark that as true, and then also copy that across and mark this one as false. And I've done the same for this. So RF in here, true here, RF in here, false here on that boolean. LLB in here, true, and then false. And then you see RB in here, true, and then false. So that is a little change that I've made, and essentially what I'm doing is I'm basically making a boolean which is going to allow us to say whether a wheel is in the air or not, because if it is in the air we don't want it to make a sound. If it isn't in the air we want it to do something essentially. So on the return value here we're coming down, and that's going into the condition of this branch. Now because it's only drawing the line trace down by 50, this return value, if the car's in the air, will essentially read as false. And if it is false, we're going to go down into a custom event, well, a call function called stop FL sound. If I double click on this, it's going to go to this custom event where we're firing off and we're doing a load of things. Now this is where it's going to be a bit tricky for me to teach, because the code for this entire system is a little bit more parallel. It's firing off in different places at different times. So to manage this, what I suggest you do is whenever I mention a custom event, go ahead and create it and just have it sort of off to the side. Don't worry about what all this is doing yet. Just have the custom event off to the side next to the call function that it's going to be attached to. And then when the time comes where we come to this bit, for instance, you'll go, oh, okay, I need the stop FL sound now, and I'll drag this off here, and then you can start sort of following along with what's happening here. So that's what I advise that you do. So that's essentially what's happening with that branch. We're coming down into stop FL sound, we're setting up these variable booleans that we've created, and you can see we're doing similar things here, basically the same thing, but it relates to those specific tyres. Now what I want to do before we continue on focusing on just the left front tyre, I want to sort of zoom out a little bit and just give you a quick overview of these so that you can just see with your eyes what's essentially going on. So this is the left front tyre. This is the front right tyre. This one is the back left. And this one is the back right. Each of these are firing off to their own lines of code. So you can see this is the front left. If I start to zoom out, now this might be scary for quite a lot of you. If I start to zoom out, what you'll see is that this entire area is for just the front left tyre. It's for taking care of when the front left tyre is on grass, asphalt, if it's on the default physical material, if it's on gravel, and if it's on the apex. If I zoom in here, you can see if I type in on the right front tyre, it's going to send us off to this custom event. And now this is exactly the same thing as this, our left front tyre, but except it's relating to the right front tyre. And exactly the same here, this is the left back tyre, and this is the right back tyre. So you can see we have 4 variations of this, which are all exactly the same, more or less, other than a few changes to make sure it works independently. And that's where these call functions are all sending off to. Before we move on, I do need to go over what's going out of the bottom of this sequence. And this is making it even more complicated now, because this is going to relate to a previous episode where we set up the tyre screech sound. So when we set up the tyre screech sound, if I move to that line of code all the way up here, and this is where this is all starting to come together and connect, and all the functionality of the entire sound system is actually going to work correctly. Hopefully, if you followed along with this episode, the tyre screech episode, you'll remember we set up this boolean and we had it set so that it was always true. So if you were driving on grass, you would still hear a tyre screech sound. And if you're only getting to this point in the episode and you haven't found a way of setting this up yourself, you'll still be hearing tyre screech sounds on like grass and loose gravel, which is not what you want. Obviously, a tyre screech happens mainly on asphalt, so that rubber and the adhesion it has rubbing against the asphalt is what creates that tyre screech sound that we all know. So this is where we're going to be setting this for this episode. So I'm going to come down and I'm going to show you how we do that. So on what surface each wheel is driving on, what we've just been writing then, out of the sequence on then for, we're coming down and we are saying, are any wheels on asphalt? And we have a bunch of booleans which we're using to essentially define that. So we're coming into a branch from the sequence on then for, and that branch is taking a condition from an or boolean, and what we're interested in is essentially any of the tyres, even one of them, touching asphalt. So what we're saying is left front tyre on asphalt, right front tyre on asphalt, left back tyre on asphalt, and right back tyre on asphalt. Into the boolean, if any one of these are true, this condition will read as true. For it to read as false, every single one of these have to be false. Now, once we've essentially defined that, if all of these are true, then we have another boolean variable that we've created called at least one tyre on asphalt, ? And we're setting that to true because we know that at least one of these tyres are on asphalt because we're going through this or boolean. So hopefully that makes sense. If all of these are false and that this is false, and we can say at least one tyre on asphalt ? No, that's false. No tyres are on asphalt based on what we have here. So these are being defined. Finally, if I get over here. So I'll get over to the next bit now where we're going to be talking about the left front tyre. Now, in an attempt to try and get back to a more linear fashion of teaching, I'm just going to follow along through here through the left front line trace. So you should have all of this. And when this branch is coming through true, we're going to be going down to this custom event. So I don't know if you have this custom event lingering around somewhere over here. If you do, drag it down to somewhere central and off this we're going to something called switch on ePhysical surface. Now this is where this data from the surface type is coming through into this call function and being carried across to this custom event. And what it's going to do is it's going to declare what surface that line trace is picking up beneath the tyre. So if it's picking up asphalt, it's going to come down here and it's going to say left front tyre on asphalt, true, which is relating to this bit we've just been through. So that's basically setting this boolean here to true. So all these could be false. This is set to true, which means this all boolean will read as true. And we can say at least one tyre is on asphalt. And we're going off onto all these different areas. So we can go off to asphalt or grass or gravel or apex for this front left tyre. I'll go over default last, which is all the way up here. I'll go over that last for a certain reason I'll get to in a moment. So for asphalt, we're coming over and we're setting this boolean LF tyre on asphalt question mark to true. Once we've set that to true, we're coming into a sequence, and the top of this sequence, I want you just for now to ignore this. We'll do this in a minute. These are all call functions which are firing off to other lines, essentially to reset these nuances on each material. So for now, I would ignore this. So on then 0, just ignore this, and I'll get to that at the end when we have all these custom events in the correct space, essentially. So on sequence, then 1, I'm using delay until next tick. The reason I'm doing this is because I had a little bug where if a tyre was just picking up in between two different surfaces, so say for instance a tyre clipped an apex, but then it quickly went back to asphalt, I was getting this audio glitch where it was like buzzing. So the delay until next tick was something I was using to try and fix that bug. I did multiple things to fix that bug and it did fix it. I'm not entirely sure if that was one of them, but it fixed it, so I'm just leaving it in. So on the then 1, we have delay until next tick, then we're going into a do once. For the reset, we have a custom event called tyre surface asphalt do once reset. So name that exactly as that, because we're going to be referencing that later on in the code. So it's important that you name everything exactly as I have done, otherwise it's going to get quite confusing for you. As long as you've named everything exactly the same as me, it should be okay. So tyre surface asphalt do once reset. Now coming out of this do once, we are finally referencing the Metasound from the previous episode, and we're doing things like, say, road hump play. So execute trigger road hump play. If I go to our front left and I go to here, so that's where this is, road hump underscore play. We're telling this wave player that it can play. So that's what we're doing here, and these are all the same Metasounds. So Metasound sound effects surface audio front left. That's what all these are. So you can see we're saying grass stop because we're not on grass, we are on asphalt. We're coming through the asphalt tree of this logic. So grass stop on that execute trigger gravel stop, execute trigger apex stop, and then we're setting float parameters with regard to the road hump, the grass fade, the gravel fade, and the apex fade. So you can see on the road hump fade, we're setting that to 1, basically saying we want to be able to hear it. So if I move across, road hump fade is set to 1. If I go to grass fade, we're setting that to 0. So go and find the grass. The grass fade is here, so that's basically setting this to 0 so that essentially it's going to fade out and we won't hear it. So that's essentially what we're doing here. Grass fade 0, gravel fade 0, apex fade 0. So carrying on here, I just went through and looked at mainly this in particular, and what I've realised is I've written this in a very quirky way. I should have just used an absolute node to convert values from the vehicle movement speed, the get forward speed of our vehicle movement components. I should have just used an absolute coming out of here. So if I type in absolute float, I can set that there, and then even if I'm reversing, that will set the negative values to positive. Instead, for some reason, what I've done is I've went through a branch and I've reset the VMC forward speed for when it's not greater or equal to 0, so that I can multiply it by -1 to then essentially get it to be a positive value. So this is a bit of a silly way that I've written this, to be honest with you. Just deal with it. If you want to write it the proper way using an absolute node, I do advise that you do that. But if you just want to sort of follow along, this is how I've done it in this case. It's a bit quirky, but it does work. But you should just have used an absolute node. I don't know why I did it this way, to be honest with you, because earlier on, up here, I do actually use an absolute node. There it is, right there. So I do it properly here from the collision metal audio system. But for some reason, I've done it really weirdly here. So I apologise for that, but that's just how I've done it. So coming out here, we're setting the VMC forward speed based on this, which you probably will have seen from the collision audio system episode. And then I'm going into this branch. If it's not greater or equal to 0, I'm taking the opportunity to convert this VMC forward speed back to positive, because if we're reversing, it's not going to be greater than equal to 0. It's going to actually go into negatives, therefore I'm setting it back to positive. This is my weird way of doing an absolute node. Now from here, out of this branch, we're coming out and we're setting the VMC forward speed from both of these now. So we're taking this one, or we're potentially taking this one if it's false. So you can see it's coming out over here, and we're taking the max value and the max value here. So essentially whichever one's positive or the largest is going to be coming out of here, and then we're taking that opportunity to set the VMC forward speed. So now that variable will always be positive. All of this could have been avoided just by using an absolute node. So I apologise for this weird way of writing. So continuing on, we can actually get to what we're here to do, which is essentially set the float parameter for the Metasound sound effects surface audio front left for this Metasound here. We are setting the float parameter of the loop gain, which is these essentially. So loop gain is here, loop gain is here, here, and I think that's it. So that's what we're doing. We're setting the loop gain based on this map ranged clamp. So we're taking that max value from our VMC forward speed, and we're saying anywhere from 0 to 120. So at 0, our map range clamp is going to map the forward speed of 0 to 0. That basically means we're turning it down to 0. We're not going to hear anything, because the wheel's not moving. If the car's not moving, the wheel's not moving, therefore we don't hear sound. If we're going 120 kilometers per hour or higher, we're going to set that range to 0.8. So that's how loud we're letting that sound be, essentially, for the loop gain. Okay, so coming out of this loop gain, I'm just going to sort of pick it up again. This play Asphalt scrub sound. So this relates to this here, Asphalt scrub, with these 4 different wave players, which are playing that little crunched rock sound that are underneath the tyres. What I've got here is I only want it to happen between speeds of 1 kilometer and 20 kilometers per hour. And I've also wrote here it's only present on the front left and the front right tyres. So the reason I want it between 1 and 20 is because if we're setting off nice and slow, you tend to hear those little small rocks and stones beneath the tyres sort of crunching. But if you're driving fast, you don't want to hear that sound. You need to switch it off, because if you're doing like 50 kilometers per hour, for instance, or more, it's going to sound quite strange if you hear small rocks slowly crunching under the wheels. So that's what we're essentially setting up here. So what we have is a branch. This first branch is saying, are we greater than 1 based on the VMC forward speed? If we are, then we're going into another branch, which is then saying, well, are we greater than 20 based on the VMC forward speed? And it can be true or false based on whatever. So if this one's true, we're leading through here. If this one is false, we're coming down into a sequence, And then on that sequence, we are setting the float parameter for this Metasound of the asphalt fade to 0. Because we're less than 1, the vehicle's basically not moving. Therefore, the asphalt fade has to become 0, which is relating to this here. Asphalt scrub underscore gain fade. Sorry, here, asphalt fade, that is being set to 0. So that we won't hear those crunch stones because we're not moving fast enough. On this sequence, on the then 1, we're coming off and we are resetting the do once so that it can be used again. So we'll get to that in a minute. Now, following across the true of this branch, if we are true and we are greater than 20, once again, we're setting the asphalt fade to 0 because we don't want to hear it. We're traveling too fast. We don't want to hear those crunched stones beneath the tires. If it's false, we are not greater than 20. Then we're setting that asphalt to 1. So between this branch and this branch, we're getting that sweet spot where we can say, yes, we want the asphalt fade to be 1 so that we can hear those nice crunched stones underneath the tyres. Then finally, both of these are coming into the do once and we're going into a multigate. And the multigate is set to is random, it's set to loop. And we are coming out and we're saying execute triggers for asphalt scrub 1 underscore play and asphalt scrub 2 underscore play, which is firing off these triggers inside of our Metasound, which ultimately is leading to these wave players playing those asphalt scrub sounds. I'll play them now just so you've got a reference for what they're playing. So if I look for my asphalt sounds, where are we? Surface noise. So it's these sounds here. So that's essentially what we're playing out with this wave player, and we have 4 of them, so that we're playing them all based on this multi-gate. So you can see Asphalt Scrub 1 play, Asphalt Scrub 2 play. So that is essentially the whole Asphalt tree. In a minute, we will go through this part of the section, but for now, I'll just leave it blank. What I want to do is now go to the grass area. So we're going through grass, therefore the left front tyre on asphalt question mark is not true, it's false. So this down here will now read as false, essentially, going into this or boolean. Now coming out of the grass, we're going to follow down. Now a lot of this is actually pretty much the same when grass physics material is used. So sequence, once again, we're going to ignore this. Then 1, again, we're going into a delay until next tick. Then we're going on to a do once. We need to be able to reset this do once for when we're not driving on grass so that we can essentially execute all this again. So the custom event we're using to reset this do once is called tire surface grass do once reset. So create that custom event exactly as it's written so that you can follow along later when we reference it later on in the code. So we have that do once, it's going to be reset at some point. Then we're using exactly the same setup here again. So we are saying execute trigger for this Metasound here from our component section. Road hum stop. We want the road hum to stop because we're not on the road anymore, we're on grass. We're saying grass underscore play, referring to the grass section here. Grass underscore play, making that wave play. We're saying gravel stop on that trigger parameter. We're saying apex stop on that trigger parameter. This set float parameter for this Metasound is being set to 0 for the road hum fade. Grass fade is being set to 1 because we're on grass, we want to hear it. Gravel fade is being set to 0 and apex fade is being set to 0. So that's essentially how that's being set up. Coming down on then 2, this is all exactly the same stuff. Essentially what we have is the loop gain. We don't have obviously the asphalt section. So to be honest with you, the majority of this is copy and paste. So let me see, you can pretty much copy and paste. I'll show you what you can copy and paste. All of this from the asphalt section. all of this coming out of that sequence, even the sequence, and paste all of that in, and all you're doing is going through and basically changing the trigger parameters so the road hum is now stopped instead of playing, and so that the grass is playing instead of being stopped. And then the next thing you'll be changing is the road hum fade will need to be 0, the grass fade will need to be 1, whereas on here obviously the road hum fade needs to be 1, the grass fade needs to be 0. And then this section, let me just check over this, make sure we are about the same. Yeah, it's exactly the same. So loop gain is being map range clamped between 0 and 120 to 0 and 0.8. And this basically continues on for the gravel as well. So if I go down the gravel section, here we go down here. Again, you can paste across all of that section from the grass section now. So just grab all of this from the grass section, copy it, paste it across here, and I'll show you what we are doing differently. So one thing to take into account, you do need to write in this custom events. This is a new custom event that needs to be written in now. So on this do once, tire surface gravel do once reset. That's what that is called. So that's a new custom event you need to create. Tire surface gravel do once reset, just to be absolutely clear there. And then here we're saying road hum stop, grass stop, gravel underscore play. Apex stop still, road hum fade is 0, grass fade is 0. Gravel fade is now 1 because we're on gravel. Apex fade is 0. Coming down here, let's see, are we pretty much the same? Yeah, exactly the same, so that's perfectly fine, so just leave as it is. Now the apex things change a little bit. Apex standard, we're coming down, once again, left front tyre is not on asphalt, it's on an apex now. Come down, and when the apex physics material is used, we're going into a sequence. Once again, you can still ignore this. So let's go through this. Delay until next tick, we're into a do once. This is a new custom event again, so you'll need to write that in, create that custom event and call it tire surface apex do once reset. Okay, so that's tire surface apex do once reset. Name it exactly like that. Then out of this do once, we are saying road hum stop, grass stop, gravel stop, apex play. So it's pretty much the same, except now we're saying apex play instead of apex stop, and the rest are all stop. And then, as you may have guessed, on the set flow parameters, it's road hum fade, grass fade and gravel fade all to 0 and apex fade to 1, because obviously we want to hear the apex sound now. Now this is where I believe we change a little bit, because we need to pitch shift the apex based on how fast the vehicle is moving. So let's go through that now. So on then 2, all of this is the same, I believe. So let me just double and triple check this. Is it the same? No, it's not. It is actually different. So let's just go through this. So I can tell that this is the same. This is the same, where we are setting the VMC speed for when it's in negative values, which you could have done with the absolute node. And then we're going into another branch, which is querying, are we greater than 10, whatever's coming out of here, which is the VMC forward speed. So in this case, it will probably be kilometers per hour. If we are greater than 10, we're coming out of a branch and we're setting this loop gain based on this map range clamp. And between 10 and 180 kilometers per hour, we're basically saying range that between 0.8 and 20. Sorry, 0.5 and 2. I don't know where I got 0.8 and 20 from. So that's how that's being essentially map range clamped to the loop gain. Then we're also setting it through to this map range clamped, and we are taking the speed of our VMC forward speed, so the forward speed of our vehicle movement components, and we're using that to affect the apex PS, which is apex pitch shift. So what we're essentially doing, sorry, I'm getting a little bit lost here now. What we're essentially doing is we're saying if we are 10, so 10 kilometers per hour, we're pitch shifting the apex down by -12, the apex pitch shift down. So I'll just go to that now just to make that absolutely clear. So on these two delay pitch shift nodes on the apex rumble area, this float graph input is being pitched down by 12. Essentially, if we are moving at a speed of 10 kilometers per hour, it's being pitch shifted down by 12. If we're going up to 300 kilometers per hour, which is very hard to get to, then we're going to be pitch shifting it all the way up to 2. So if it just so happens we are actually going that speed, it's going to pitch shift it up by about that much, essentially. So that's essentially what's happening and how we're communicating with the apex part of that Metasound, the apex sound of that Metasound. One thing I didn't cover is out of this branch, if we are not going 10 kilometers per hour, we're setting the loop gain of that apex to 0. So loop gain overall is just getting set to 0, which means you won't actually hear the apex sound because you're not going over it quick enough to hear the rumble of that apex. So the loop gain would be set to 0, therefore we won't hear anything coming out of it, basically. It'll be silence. Okay, now before I go over what's going on at the top of these sequences on each of these individual materials, come up the asphalt, the grass, the gravel, and the apex standard physical material, physical surface, let's go over what's happening at the defaults. So if I go up here, we're going into a sequence which says then 0 and then 1. You can also see there's a custom event here called stop FL sound. So if you have this custom event somewhere lingering down here, I suggest you go grab that and bring it over here. And what this is doing is it's doing two things. The first thing it's doing is when the line trace is above 50, it's not going to be hitting the ground. Therefore, the left front tyre is in the air. So we're going to say stop FL sound. That's firing off into this sequence. In the event we're also driving on, or if we're driving on the default material, which is essentially a material that is not classified. Say for instance, you place a box in your level and this box does not have a material, a physical material that you've attributed to it. It will just give it the default material. So if you drive over that box, that is when this default class will be used and it will fire off up here. It will also be used, this line of code will also be used if the tyre's in the air, because we're going to be basically coming down this branch here false when the return value is false on the line trace, which means that the tyre must be in the air because the line trace is, it's high enough that it's not touching the ground, essentially. So hopefully that makes sense. So this is logic for when the default physics material is used. And it's also logic for when the left front tyre is off the ground. So once again, we are going to ignore the top section of this sequence. We will go over that in just a moment. So we are going through delay until next tick, like we have on all of them. We're doing a do once. On this do once, once again, we have a custom event which says tyre surface default do once reset. And then from here, we're setting the road hump fade to 0, the grass fade to 0, the gravel fade to 0, the apex rumble fade to 0, and the loop gain fade to 0. So we're just basically making sure all the sounds are silent. Now with that, we are finally ready to cover what's going on at the top of these sequences. And basically the top of these sequences are all about resetting these nuances. So for instance, if we are in the default physics area, so we've come out of here, we've fed the surface physics through here, And the switcher said, okay, based on this data, we are in the default branch. So we're going through the then one, the delay tick, and then we're using up this do once. But the problem is, let's say we go from a default physics material to an asphalt physics material, and then we go back to the defaults. Well, we've used the do once, so we need to be able to reset it. We need to be able to reset all of these do onces for each of these branches. Otherwise, essentially the system won't work once we've used them. So that's what's going on through the top of these sequences. So we've created all of these custom events, and what we're essentially doing is, when we are in, say, the default physics material, we are firing off to each of these custom events on the other corresponding parts of the branch, essentially, to reset each of these nuances. So I'll go through them with you now, and that will pretty much be the entire left front tyre done and explained, and we'll be into essentially explaining the differences for these. So out of the top of this sequence, for when we are in the default physics material, we are sending off these call functions to the corresponding custom events. So we're sending it off to tyre surface asphalt do once reset. So we'll make sure the do once inside of the asphalt part of the branch is being reset. Tyre surface grass do once resets. That call function is firing off to the grass do once. Tyre surface gravel do once reset is firing off to the gravel do once, and then the tyre surface apex do once reset is firing off to the apex do once, essentially. So if I click on this, you can see, double click on it, it'll take me down to this one, which is now going to fire off into that reset for when we are inside this part of the logic. And we're doing that for every single one. So on the defaults, you can see we've got the asphalt, the grass, the gravel, and the apex do once as resets. But on the asphalt, we are resetting the default now, because we're not in the defaults. Therefore, we need to come back and make sure that this do once is reset. But we're also resetting the grass again, the gravel, and the apex. The reason we're doing this again is because we could drive from asphalt to grass, or we could drive from asphalt to gravel, or asphalt to an apex rumble strip, or asphalt to a default physics material. There's no way of us knowing when we're coding this what the tyre is going to go to. It could go to anything because the player's in control. Therefore, we need to make sure that we reset all the ones that are not being used, just in case they had been used in the past. So for the asphalt, once again, that's the default, grass, gravel, and apex do once resets on these custom events. If I go down to the grass, you can see it's the default, asphalt, gravel, and apex do once is being reset. If I go down to the gravel, it's the default, asphalt, grass, and now the apex. And if I go down to the apex, it's the default, asphalt, grass, and gravel do once is being reset. So that is the entire front left tyre now. Now, what I will go over is the subtle differences between these. So obviously that is just one tyre, and we are firing off also to the right front tyre. So if I go over here, this is now the right front tyre, and we have a whole other, basically an identical thing, but some things are changing. So I'm going to go over essentially what's changing now. So you should have, what I would suggest you do is copy all of this and just paste it across here. And what it's going to do is it's essentially going to create for you new custom events. So this custom event won't have a name. And what you'll need to do is you'll need to go in here and name it RF tyre sound. And based on that being called RF tyre sound, then you'll have this call function which can fire off down to the RF tyre sound. And the same for here, the stop FR tyre sound. is referencing this stop FR sound. So this is what I mean when I say it's hard to teach, because it's so parallel. I think this is probably going to be one of the most longest episodes, come to think of it. So you're going to paste that across, and all those custom events need to be renamed accordingly, so that they are renamed with the correct naming convention, essentially. So if I go across here, you can see this is called stop FL sound, where this one is called stop FR sound for front right. So if you just keep that sort of naming convention in mind, you should be able to get through this. So now what I'm going to do is go through these highlighted sections just to show you which areas are different. So for the front right tyre sound, so it says this is exactly the same code, except we need to rename the custom events to be unique to the right front tyre. We also need to change all of the references from the front left Metasound to the new duplicated front right tyre Metasound. So this is our front left Metasound, and this is our front right Metasound. We have all four of these loaded in to the components section here. So let's go over this. So you can see here I'm referencing Metasound sound effects surface audio front left. Every single area where this is being referenced needs to be changed to the front right. So if I move across here, you can see Metasound sound effects surface audio front right. So I've just dragged that in, and then from here I've connected this to all of this, and the same here. So anywhere where the front left was being referenced, now the front right Metasound is being referenced. So hopefully that makes sense. So you have to go through and make sure that once you paste that across, you give it the front right Metasound reference and not the front left. Okay, so we've done that for every single one, from the default material all the way down to the apex material in the front right section. The other thing was the custom events being renamed, which hopefully you'll be able to get through that. So new custom events created on paste, name them. So when we copied and pasted these across, these will need to be renamed. So you can see this is FR default resets, and all of these have been renamed. So this is now FR asphalt resets, FR grass resets. I'm not going to go through them all. Hopefully you'll get the point and you'll be able to get through this on your own. These will need changing to the newly created custom events. So when we are trying to fire off to the corresponding nuances on the other materials, and we rename these custom events, you want to check that these call functions are renamed along with the custom events to make sure that when the top of these sequences fire off, resetting all of these nuances, that they are actually going to fire off to the correct area. Now, is there anything else? Oh yeah, on the front right, if I move to the asphalt section over here, this is an area that we've changed. So previously on the front left, we are sending off execute triggers to the Asphalt Scrub 1 play and Asphalt Scrub 2 play for the Metasound surface audio front left on both of these. So we're going through here and we're firing off Asphalt Scrub 1 play and Asphalt Scrub 2 play for these wave players. But we want a stereo effect for this tyre scrub sound. So on the front right, we don't want to send it through, we don't want to be triggering those Metasounds again. We want to trigger the other ones so that we have a unique sound for the stones underneath the tyres. So going to this section now, so this is in the asphalt section of the right front tyre sound. Going across, we are not triggering the Asphalt Scrub 1 and 2. We are triggering Asphalt Scrub 3 and 4 play for the Metasound. If I follow these blue lines, if you see the target, you can see all these blue lines coming up, and the reference is not the Metasound front left, it's the Metasound front right. So on the Metasound front right, we are firing off for Asphalt Scrub 3 play and Asphalt Scrub 4 play. So this is our front right Metasound. That's why this is in red, because these aren't being used anymore, the 1 and the 2 on these triggers. We're using the 3 and the 4 firing off for these wave players. So that is the main changes for the front right. Now you're going to have to go through this again and copy and paste this across this one now for the left back tyre sound. And the main changes for this, it's all the same changes, so you're going to have to go through these custom events, rename them, go through these call functions and make sure that they're all being sent through to the correct custom events for the do once resets. You're also going to have to make sure that you change this Metasound reference to the back left. So this is the front left Metasound, this is the front right Metasound, this is the back left Metasound. You need to make sure that these references are sending through to these now. So hopefully at this point you'll be okay to go and do this by yourself. The other thing is that we don't have any Asphalt Scrub sound being emitted from the back tyres. So we can go ahead and delete all that. That's why I've got this as a little green comments, just basically saying you can delete this part of the code that will have been copy and pasted across from here. And then if I move across to the back right tyre, you're basically treating this exactly the same as the back left. And the front right, you need to go through, change the custom events, change the references to the back right Metasound now, so that you're triggering the correct unique Metasound. And once again, there's no tyre scrub. So hopefully you understand that procedure. And provided you do understand that procedure of how to copy and paste these across, because it would just be, there'd be no point in me going across every single one and being, you know, that specific about how to do this. If you understand this, it will be possible for you to go and do these other 3 tyres on your own. If you do need help, just let me know in the comments, but I will show you this working now so that you know what I've written down actually does work. Right, so the first thing we want to check is the Asphalt Scrub sound. The tyres are currently on the asphalt. You can see our little laser on the front left. Lasers are coming down from all the tyres. I only have the one switched on the front left at the minute. So if you remember rightly, we defined we want to hear the Asphalt Scrub sound only when we are above 1 km/h, but we can't be above 20 km/h because we deem that as too fast to hear those little small stones going underneath the tyres. So if I accelerate and keep it below 20 km/h, you can hear those little sort of stones underneath the tyres scrubbing away basically. If I accelerate quickly and go above 20, you won't hear them. So there's no stones playing now because we're going too fast, in my opinion, to hear those stones. If I drive on this apex, you can hear that, and you can hear it over to the right because it's being played from that side. If I drive on grass, you can hear grass. If I go ahead and come all the way around, I can drive on the loose gravel which I've set up just outside of the tunnel, and you'll hear that loose gravel. The other thing, you just heard the tyre screech then. That tyre screech should only be present on asphalt now. If you try and slide about on grass or gravel, you won't hear it essentially. If I come up to this, you can hear the loose gravel. So it's all working correctly now. If I leave this, and that should all be working fine for you now. Let me know if you have any trouble with it in the comments, and I'll try my best to help you. This was definitely one of the most toughest episodes I've ever tried to teach, with it being so parallel and not as linear. So hopefully, I did my best, I tried. Hopefully that came across, and you can get to grips with it. So if you do have any troubles, let me know in the comments. Thanks for watching. I'll catch you next time.